Hello friends, welcome to today's lecture, Shear Force and Bending Moment. Myself, Mr. Y.S. Patil, Department of Civil Engineering, Sharad Institute of Technology, College of Engineering, Ketrao. So in this lecture, we draw SFD and BMD for a given beam. This beam AB is simply supported and having three loads, that is first 30 kN point load, 20 kN point load and 10 kN UDL having 4 meter length. So first of all we calculate support reactions RA and RB. So in this system there are total 5 forces including 2 reactions, that is 30 kN, 20 kN and UDL of 10 kN intensity. It is an external applied force, and RA and RB is a reactions. So RA and RB going in upward direction and remaining that 3 forces going in a downward direction. So first of all plot upward forces, that is RA plus RB is equal to 30 kN downward force, 20 kN downward force and the UDL, that is 30 plus 20 into length of plus, that is intensity of UDL is 10 into length of UDL is 4, that is 10 into 4 40 plus 20 plus 30. So total downward load is equal to 90 kilonewton. Then next summation M is equal to 0. Taking moment about A. Taking moment about A for all forces. For RA, the line of action coincides with A point, means there is no moment for RA. Then next, this is the 30 kilonewton. Direction of the moment is clockwise. Then this 20 kilonewton. Direction of the moment is clockwise. And this next UDL. The direction of the moment is clockwise for this UDL also, and this RB going in upward direction. So with respect to A, the direction of the moment for RB is anti-clockwise, means this RB moment plot one side and remaining 3 forces moment plot another side. So first take moment for this 30 kilonewton. That 30 kilonewton, it is a force. From that, with respect to A point, the distance for that 30 kilonewton is 2 meters. So 30 into 2 plus next 20 kilonewton force. From that point A, distance for 20 kilonewton force is 2 plus 2, that is 4, that is 20 into 4. Then next UDL. At UDL, first of all convert this UDL into a point load. So total length of UDL is 4 and intensity of UDL is 10. So first of all plot 10 into 4, means it is a total UDL. Then next, where it is act, the total UDL act on the midspan of this UDL, means that BD. So length of BD is 4 meter. So 4 meter by 2 is 2 meter. So means act on this point. So from A point, distance for this point is distance AD, means that is 2 plus 2 4 plus half of this BD. So 4 by 2, means this is a 4 plus 4 by 2. Then is equal to RB into 8, span of the beam. So by calculating this equation, solving this equation, we got RB is equal to 47.5 kilonewton and RA is equal to this. If you know the first of all RB, then put up this RB in this equation, that RA is equal to 90 minus 47.5. Then we got RA is equal to 42.5. This is the reaction RA and RB. Then next, shear force calculations. Once again, first of all draw the sign conventions. So consider right side upward force, consider minus, downward force consider plus. All points having 2 shear force values, right and left. B, first of all starting with B point. So mark a section on the just right side of the beam B point and consider right side. So number of forces on this right side is 0. So that's why SF at BR is 0. Then next, section number 2, mark a section at B just left side. So number of forces on the right side is RB. Then RB value is 47.5 and the direction of the force is upward. So upward force consider minus, means SF at BL is minus 47.5 kilonewton. Then next, mark a section D right, means just right of the D. Now consider this side. So total number of forces on this side is RB and intense and UDL. So RB going in upward direction and UDL going in a downward direction. So RB consider minus and UDL consider plus. So RB value is minus 47.5 plus intensity of UDL is 10 and length of UDL is 4. So 10 into 4, 40. So minus 47.5 plus 40 is minus 7.5. Then next, mark a section just left side of D and consider right side of this section. So number of forces now 1 RB, second UDL and third 20 kilonewton. So plot upward force minus downward force plus. So minus 47.5 plus 10 into 4, that is UDL, plus 20. So answer become, this is a plus 12.5. The answer is plus 12.5. Then next, consider C right, means mark a section at the point C just right. And once again consider right side. Number of forces same, 3 forces RB, UDL and 20 kilonewton force. So whatever the calculations for DL remain for the, it remains same for the CR. So answer is 12.5 plus. Then consider section on the C just left and now consider the side, right side of this section. So number of forces now RB, UDL, 20 kilonewton and 30. Plot all forces. So number of forces is 4. So minus 47.5 plus 10 into 4, this is, then plus 20 and plus 30. So answer will be 42.5 kilonewton. Then next, AR is same as good as that CL because no force in between A to C. So answer will be 42.5. And AL means considering these all forces, because we know the RA value is 42.5 and going in upward direction. So plus 42.5 minus 42.5, it becomes 0. This is the shear force value for this beam. So now plot the all values. Now BR is 0, then BL is minus 47.5, minus whatever the minus value plot below of that baseline, that is 47.5. Then next DR is minus 7.5, then DL is 12.5, CR is a 12.5, CL is 42.5, AR is a 42.5 and AL is 0. So join all coordinates by straight line and this is your SFD. Now see, in between A to C, there is no load. So shear force line or diagram is horizontal straight line. At point C, there is a point load. So shear force change vertically. Then next, once again C to D, there is a no load. So shear force diagram is C to D is horizontal straight line. At point D, there is a point load. So shear force diagram change vertically. And in point between D to B, there is a UDL. So from this point D to B, shear force diagram is inclined straight line. So this is the relation, or this is the relation between that loading and shear force. Means if there is a no load in the span, SF diagram will be horizontal straight line. If there is a point load, SF diagram will change vertically, and if there is a UDL, SF diagram will be inclined. Means where UDL is there, SF diagram should be inclined straight line. So this is the SFD. Next, we draw BMD. For BMD, once again sign conventions: right side anti-clockwise positive, clockwise negative; left side clockwise positive, anti-clockwise negative. Once again, bending moment at A and B will be 0 because they're simply supported ends. Means bending moment at A and bending moment at B is equal to 0. Then next, bending moment at C. Now consider a section now exact on point C. So number of the forces on the right side is 20 kilonewton, UDL and RB. So number of forces on the right side is 3 forces, 1, 2 and 3. And that for the left side is only one force, that is RA. So consider minimum force side, that is left side. So direction of the moment for RA with respect to C is clockwise, and left side clockwise moment is positive. So 42.5, this is the RA value, into 2, that is 85 kilonewton meter. Then next, consider or calculate bending moment at D. Now mark section on exact point D. Now on the right side, number of forces 2, that is first RB, second UDL, and on the left side also 2 forces, that is RA and 30 kilonewton. Whatever you want to consider side, consider right side or left side. Both answer will be same or right one. So first I use right side. Number of forces on the right side is 2. That is first one RB. Direction of the moment for RB is anti-clockwise. So anti-clockwise moment on the right side consider positive. And for that UDL is clockwise. So clockwise moment consider minus. So RB value is 37.5 into 4. Sorry, that RB value is 47.5. So 47.5 into 4. This is the anti-clockwise moment. Anti-clockwise moment consider positive. Then UDL, for UDL, intensity of UDL is 10, length of UDL is 4, that is 10 into 4, and where it is at half of this BD portion. Half means that 4 by 2. So distance is 2 meter. 4 by 2 is a 2. So bending moment at D is 110 kilonewton meter. So plot all points, that is first bending moment at A and B is 0. Then at C 85 kilonewton meter, and at D 110 kilonewton meter. Now see here carefully. There is no load between A to C. So join straight line. A to C join straight line. Then next, from point C to D there is a no load. So once again you draw straight line up to this D point, and this is the straight line. Means AC straight line, CD also straight line. Now in portion D to B there is a UDL. So whenever the UDL acting on the beam, at that point you should draw the BMD diagram by using parabolic curve. This is not a straight line, this is a parabolic curve. So you should draw free and parabolic curve. Once again I repeat, if there is a UDL on the beam, you should draw BMD as a parabola. In between A to C there is no load, so this is the straight line. In between C to D no load, this is the straight line. it should be straight line, and in between D to B there is a UDL. So this DB portion up from D point to B point, you should draw a parabola curve. Thank you.